expected to determine the equation of a tangent to a circle. Right? The good thing is that last year you did the circle geometry theorems, and one of the theorems says that the angle between a tangent and a radius at the point of contact is equal to 90 degrees. So if you draw a radius and then you draw a tangent, right? The angle between the two will be equal to 90 degrees at the point of contact. Right? Because the tangent and the radius will be perpendicular. So if they are perpendicular, we can use our knowledge of perpendicular lines. Remember, in grade 9, grade 10, you were taught that if two lines are perpendicular, the product of their gradient will give you what? -1. You did that in grade 9 and 10. I think more in grade 10. Alright? So no, it's not grade 11. Right? It's grade 10. So what that means is, if a tangent and a radius are perpendicular to each other at the point of contact, it means in analytical geometry we can determine the gradients of both the tangent and the radius. Or sometimes it can be the tangent and the diameter. They are the same. Okay? That's why when you did that theorem from cycle geometry, we can write the theorem as tan perpendicular to radius or tan perpendicular to diameter. Okay? So, you need to remember that the gradient of the radius times the gradient of the tangent will always give you a product which is equal to -1. Right? Why do we need this? We need this equation because in grade 12, in analytical geometry, you may be asked to determine the equation of the tangent to a circle. So to find the equation of a tangent, you need the gradient of that tangent. Okay? Then you substitute into the equation y equals mx plus c. You also need a point on the tangent, and usually the point will be the point which is at the point of contact. Right? So you substitute your m, which you get using this equation, then you substitute x and y at the point of contact. Or if there are no points at the point of contact, then somehow you must be given any point along the tangent for you to determine its equation. Alright? So make sure you remember this equation. And you remember this from your grade 11. Now, for your June exam, I put a question on finding the equation of a tangent. You have to know it. Okay? I think it's 4 marks. Right? So you need to know how to determine the equation of a tangent. To do that, you have to find the gradient of that tangent, then substitute a point along that tangent. Okay? Alright? I'm surprised that people are copying this because yesterday I sent you this on the group and I told you to copy it down. And in actual fact, I sent you twice. Okay. Alright. I said copy down the notes. I said copy down. And I didn't say copy down here. Yesterday, I didn't give you homework. Alright. Can I have your attention? Okay, boys and girls, please be aware that Mr. Ponda spent 2 days doing mobile verification in the homework. The reason why, I don't want anybody in the near future, you are writing your maths paper 2, either in the June exam, the trial, or the final. You see a question of maybe of that type. Then you say, I never did this. I showed you that you can encounter some challenging questions. Okay? And I've shown you that. That's why there's a reason why I spent 2 lessons. One method, which was an assumption method, there I did a method with no assumption, which is the best method. All right? Okay, then another aspect, finding the length of a tangent. By now you should know that length is the same as distance. Okay? So when you want to find the length or the distance of a line, which is a tangent, you can use the distance formula. Or if it's part of a triangle, which sometimes it's possible, you might need the theorem of Pythagoras. But for you to use the theorem of Pythagoras, it means that tangent must be part of a right-angled triangle. Remember, the theorem of Pythagoras is only used if you've got a right-angled triangle. Okay? If you've got a right-angled triangle, then you can think of using the theorem of Pythagoras to calculate any one of the lengths of the 3 sides. Okay? But you must be given 2 sides of that triangle. Alright? So we are going to need that. The good thing is, you know the distance formula from grade 10, you know the theorem of Pythagoras from your grade 7, grade 8, somewhere there. So you should be able to apply that. Okay, so let me just do an example. Right. Okay, so we've got an example here. Right. This is what you should expect. You must have a diagram, then you get questions from it. So the question says, in the sketch alongside point P, where x is -3 and y is 1, obviously that's the center, is the center of the circle. Then AB is the tangent to the circle at Q equal to Q, where x is 1, y is 1, which is this point. Right? The point Q is in the 4th quadrant, and point P is in the 2nd quadrant. So the first question says, determine the equation of circle P. Right? You need to find the equation. Right? Now, if you want to find the equation, you need 2 things. Number 1, the coordinates of the center of that circle, which in this case, the coordinates are given. Then you need the length of the radius, right? Which is not given here. But we know that the distance from the center, right? The distance from the center to the point of contact with the tangent is called the radius, right? Which means that angle will be 90 degrees. At this stage, we are not trying to determine the equation. That's part of A2. We just want to find the equation. So we have to calculate the radius of that circle. Okay? We have to calculate the radius of that circle. Okay? So let's calculate the radius of PQ. Sorry, the length of PQ. PQ is the radius. So here I'll say radius R, which is equal to PQ, is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. This will give you the square root of x2. Okay, now x2, it's your choice now. You can choose the coordinates of P as your x2, y2, or the coordinates of Q as your x2, y2. I'm going to choose the coordinates of P as my x2. So I'm going to put -3 minus x1 is going to be 1 squared plus y2 is going to be 1 and my y1 is going to be -1. Okay? Please, it's your choice in terms of deciding which coordinates will be x2, y2, x1, y1. Alright? Then, here you end up having -4 all squared plus 2 squared. Please use a calculator if you are not sure. 1 minus minus 2 gives you a positive 2. Alright? So, our radius is going to be the square root of 16 plus 4. And this will give you the square root of 20. Okay? Now I'm smiling, I know the radius. And I know the coordinates of the center. Therefore, the equation of the circle will be x plus 3. Okay? Remember the general equation is x minus a squared plus y minus b squared is equal to r squared. So if the x value at the center is negative, you put the negative value there, you end up having a plus. Are you following them? Right? So this is squared plus y minus 1, because y is positive there, squared. Then this will be equal to the square root of 20 squared, which you can write as x plus 3 squared plus y minus 1 is equal to 20. And then you are done. Okay? Right? Are you following them? Are you following? Yes, paper 1 and 2. Nothing else. Yes. Okay, what I'm going to do, okay, since I'm the grade coordinator, okay, I'm going to send you the, okay, I'm going to send you the breakdown, right? For both paper 1 and what? Paper 2. I'll do that today, after this lesson. So I'll send you 2 things, effort 3. The June exam question paper and memo plus the breakdown. No, it's June. Okay. Can I carry on? Can I carry on? Alright. I'm going to carry on. Please, can you stop talking? Alright. So let's move on to the next question. The next question says, determine the equation of the tangent to AQB. Right? Actually, it's tangent AQB. So AQB is the tangent. Alright? So if I want to find the equation of the tangent, I need to know its gradient. But I can't calculate its gradient directly because there's only one point along that tangent. So I have to use the gradient of the radius first. So I have to calculate the gradient of radius. So m is going to be y2 minus y1 over x2 minus x1. Then I'm going to use x2 and y2 as the coordinates at P, and then my x1, y1 is the coordinates at Q. So y2 is going to be 1 minus y1, that's minus 1. Right? Then x2 is minus 3 minus x1, which is a 1. So if you simplify this, you get 2 over minus 4. And this gives you minus a half. Okay? Which makes sense because the line PQ is the radius. It's slanting to the left, which means the gradient must be negative. Alright? Then we now need to calculate the gradient of the tangent. So we use the formula m rad times m tangent. This should give us negative 1. Okay? So we substitute now the gradient of the radius. It's minus a half times m tangent. This should give us minus 1. Okay? Now, when you get to this point here, you don't have to get nervous. What you just have to do is, since there is multiplication here, this multiplication here, can you look please? See that multiplication there? we want the gradient of the tangent. So you just divide both sides by minus a what? A half. Are you following what I'm saying? Yeah, there's no need to get confused yet. We want M tangent. Usually, if you practice a lot, you are going to see that if the gradient of the radius is a fraction, the gradient of the tangent must be an integer. Okay? And vice versa. Right? So, our gradient of our tangent is going to be minus 1 over minus a half. And the answer will be a 2. So if the gradient of the radius is negative, the gradient of the tangent will be positive. Okay? And if the gradient of the radius, like in this case here, is a fraction, okay? Yes? No. It's almost break time. Is it very critical? Okay. All right. So here our gradient of our tangent is going to be 2. Now we can smile now. We now know the gradient of the tangent, and we are given a point here along the tangent. So we can then use that point and say y is equal to mx plus c, because the tangent is a straight line. Therefore, its general equation is y equal to mx plus c. So where there is y, we put minus 1, right? Where there is m, we put 2. Where there is x, we put 1. We want to calculate the y-intercept. So this will give us minus 1 equal to 2 plus c. We take the 2 to the left, we get minus 3 equal to c. Therefore, the equation of the tangent will be y equal to 2x minus 3. This will be the equation of that tangent.
So how many marks is that?
Well, for the equation of the tangent, it could be 4 marks. Right?